Okay, guys, let's begin. So today, what we're going to do is we're going to first review mass moles to grams conversions and do the reverse calculations. Like I'm pretty sure last week we just converted between grams to moles. And this week we're going to review that and also convert between moles to grams. And then we're going to do something called mass percentage. And we're going to do that calculation. That's what we're going to do today. So for the homework for this week, there are 4 questions in a Google Class under the class work tab in Google Classroom, just like any other day. It's already posted right now, so that's good. And as usual, I'll give written feedback and post your grades on Google Classroom so you can see your grades. And as always, if you have any questions about the course or any suggestions to improve this course, feel free to email me at this email. So for today, we're going to review grams to moles conversions. Then we're going to do the reverse, moles to grams. And we're going to tackle this with the dimensional analysis strategy I talked about last week. We're going to review that strategy today. And then we're going to do mass percent calculations at the very end. So we can learn more about the stoichiometry and more math. Like last week, I would highly recommend if everyone has a calculator today, because a calculator is necessary to solve these problems. A phone or a computer works as well. So any type of calculator. So let's review grams to moles conversions. As always, a pencil and paper would always help to do these problems, but if you can do it with just a calculator or in your mind, that's perfectly fine as well. But I recommend pencil and paper. And we're going to use dimensional analysis to solve these problems. So I want to emphasize that molar mass is the most important conversion factor in any of these problems. And remember, we can calculate the molar masses by looking at a periodic table and doing the sum of the individual atomic masses. So if you go to the table, you can find that the molar mass of ethanol, which is C2H6O, is 46.1 grams per mole. So since we know this molar mass, we can write that as a fraction of 1 mole equals 46.1 grams. So we know that 1 mole of ethanol is 46.1 grams of ethanol. So then we can divide both sides of this equation. I'll call it equation 1. We could divide both sides of equation 1 by 46.1 gram per mole. So if we do that, let me do it right now. Grams is C2H6O. And let me write that on this side as well. Notice that this fraction right here equals 1. So we know 1 mole over 46 grams of ethanol is equal to 1. Since we know that this fraction is equal to 1, we could take the reciprocal, and that's equal to 1. So both of these fractions are equal to 1. So now we use these fractions to help us convert between grams to moles. So now suppose we have like 10 grams of ethanol. By dimensional analysis, this method is basically just canceling units. You start off with what we have. The only thing we have is 10 grams. So we write it right here. And then we use molar mass as a conversion factor. Remember on the last slide, it's 46.1 grams per mole. So that's the molar mass. We want the grams on the bottom so we could cancel out the grams on the top. So after we cancel grams and grams, since we're multiplying them together, we can do 10.0 over 46.1, and that's 0.1217. And the units are the units we want, which is in moles of ethanol. So that's how we can convert from grams of ethanol to moles of ethanol. We divide by molar mass. So this is the molar mass, which I'll abbreviate MM. and we can calculate that from the periodic table. So here's an example problem. So please type in your PM private message me this in the chat when you got it. So how many moles are in 10.00 grams of nitrogen gas? The molar mass of nitrogen gas is 28 grams per mole. So when you have it, please type in your answer in the chat. Okay, I see a lot of correct answers. I'll give you some more time to think about it. So I realize some people need some more time. So I'll go over it again from the whole setup. So what do we have? The only thing that we have right now is we have 10 grams. So we need to start with what we have. So 10 grams of N2. And now remember, molar mass is the key to our conversion. So we know it's 28 grams per mole, but we want the grams to be on the bottom so it cancels out. So we have 28 grams of N2 over 1 mole of N2. So we could cancel out the grams and the grams. And our result is about 0.36 moles of N2. And everyone who typed anything in the chat got it right, or 0.357. So it's the same. So good job, everyone. I think you guys all got the hang of it. Let's do 2 more just to make sure. And this time it's a little trickier. So how many moles are in 100.0 grams of hydrochloric acid? So HCl is the hydrochloric acid. As always, put your answer in the chat when you've got it. And you can approximate the molar masses of hydrogen. Like hydrogen, you could just assume to be 1. Chlorine, you could just assume to be 35.45. There's really no need to carry out too many excessive decimals for these calculations. So these calculations aren't terribly hard, but they might get a little harder in the future once we start adding more and more steps to these calculations. So I'll give a little more time just in case you need some extra time to think over it. But remember, the number one thing we need is molar mass. Molar mass is the way we convert from grams to moles, or vice versa. Molar mass. So I gave you the elements molar atomic masses. So try to find the molar mass of HCl from the sum of the atomic masses. Okay, I'll get started with the solution. So the first thing we need to do is find the molar mass. So it's 1 for hydrogen and 35.45. There's 1 hydrogen atom and there's 1 chlorine atom. So the molar mass is 36.45 grams per mole. And always, if we want to convert grams to mole, we start off with what we have, which is 100 grams. And then we want the grams to be on the bottom, so it cancels out. And we multiply it by our molar mass, grams per mole. And remember, the units of molar masses is grams per mole. So grams cancel out with the grams. And what we're left with is, if you do the calculation, you get 2.74 mole of HCl. And yep, that's what the answer says, so that's good. So this one wasn't too bad. You just had to find the molar mass as well. Now let's do one that has a little bigger numbers. So how many moles are in 45.6 grams of lead chromate? PbCrO4 is lead chromate, and we're given that the molar mass of lead chromate is 323 grams per mole. So as always, type in your answer in the chat when you got it. I do agree, this one might be a little easier because I gave the molar mass. But I'll give you a few more seconds to see if you can solve it. As always, we're going to start with what we have, which is our grams. So we have 45. I'm going to be a little lazy and just put grams. And then we need to multiply it by the molar mass, which is 323 grams per 1 mole. Since we're multiplying them together, the grams cancel out. So we get about 0.14 mole. And that ends up being the correct answer. Yep. So that was a review of what we did last time. Now we're going to do the reverse. Last time we talked about grams to moles. This time we're going to convert moles to grams. So like the previous calculation, we're also going to use the same strategy. Everything's going to be the same, except it's going to be a little different with our conversion factors. So that's why you need to put units, so you don't like memorize how to do it. So suppose we have 0.217 moles of ethanol, and we wish to convert it to the number of grams. So as always, we need to start with what we have. So the number one thing we have is 0.217 moles. So that's going to be our first thing because we're given that. And then our conversion factor would be molar mass, as like the last problem. But notice that it's 46.1 on the top this time and not the bottom. The reason is because we want to cancel out the moles of ethanol. So the moles of ethanol get canceled out. So that's why we're multiplying it by the molar mass this time. Okay, let me write this as the molar mass. Or we can get it from molar mass. So we're going to cancel out the moles. So once we put that into our calculator, 0.217 times 46.1, we get 10.0 grams of ethanol. So we can also do it the reverse way. So moles to grams or grams to moles. And it's going to be using molar mass. So I'll let you guys have a try on this one. So how many grams are in 0.357 moles of nitrogen gas? The molar mass of N2 is 28 grams per mole. So please put that in the chat when you have it. So this one's a little trickier because it's not the same habit like we have in the previous problem where we could just divide by the molar mass. That's why I actually prefer the molar mass, the dimensional analysis method, so you don't make similar mistakes. So I'm going to do the whole problem with you so you guys know how to solve these. So we always start with what we have. What we have is 0.357 mole of N2. Remember, a mole of N2 is just a number, just like a dozen is 12. It's just an arbitrary number. And then we need to use molar mass. But the key is we want the moles to be on the bottom so it cancels out with the moles on the top. So we're going to put it as 28 grams of N2 over 1 mole of N2. And then the moles cancel out like previously. So in this case, we're actually multiplying the two numbers together. And it's about 10 grams. Oh, this is a 2, sorry. So pay careful attention that we're basically just using this molar mass, but we have to make sure we put it on the right spot so we could cancel out the moles. So that's how you do one of these problems. So does that make sense?
Yes.
Okay, good. So just use the molar mass. Okay, let's go to the next problem. There's a few more so you can get some more practice into this because it's different from the last type of problem, but only slightly. So we're going to do the same thing of HCl, but this time I want you to tell me how many grams are in 2.74 moles of HCl. So as always, please type your answer in the chat when you're done. Okay, I see that more people are getting it right now, so that's always a good thing. If you're stuck on it, remember like the previous problem, molar masses are key. So just calculate the molar mass. So I'll start solving it now. So because we did it earlier, I'm not going to recalculate. It's 36.45. And remember the units is grams per mole. So the only thing we have is 2.74 moles. And the only thing we want to find is the grams, so we use molar mass. Because we want to cancel out the moles, we're going to multiply it by the molar mass. So then the moles cancel out. And once we put that into our calculator, we get about 100 grams, give or take, which is our correct answer, I believe. Yep, 100 grams. So if you remember clearly, in the beginning, we had this problem in reverse. So I asked, there was 100 grams of HCl, how many moles are there? And we answered 2.74. In this question, I said there's 2.74 moles of HCl. So we should technically get back our original answer of 100 grams. So that was basically the same problem in reverse. And this one is also the same problem in reverse. So we have 0.141 mole of lead chromate. How many grams are there? So please type in the answer in the chat when you have it. Okay, I'll go over the problem now. Oh, sorry about that. The answer already came, but it's the same as always. You start off with what we have, 0.141 mole. And then our special conversion factor is the molar mass, which will multiply it by 323 grams per mole. If we start off with gram, we'll have to flip over the orange factor, but we're doing it this way so we could cancel out the moles. And then we get this answer down here, 45.6 grams of lead chromate. So I hope this makes sense. This concludes our mole to gram calculation and gram to mole calculation. On our homework, there's going to be 2 questions about this, one from moles to grams and one from grams to moles. So to solve it, I'll just do dimensional analysis and make sure you cancel out the right units so you don't make a mistake. So now let's move on to our next topic that we have, which is our last topic for today, mass percent. So this is something completely new that we have never covered before. Okay, so let's briefly define what a mass percentage is. So suppose we have a compound with formula A and B, where A and B are elements. So one such example is H2O, which is water. So that's in the form AB. So A would be H and B would be O. But AB can be anything. It can be CO2. It could be NaF. It could even be HCl, which is the hydrochloric acid that we calculated in the previous problem. So this format can be any compound in the world, basically, as long as A and B are elements. So here's the definition, the textbook definition. The mass percentage of A is the parts of A per 100 parts of the total by mass. I know that might be a little confusing, so I'll break it down. Let's start with HCl example. So the mass percentage of H in HCl equals the weight, grams, of hydrogen over total grams. times 100. The reason we times 100 because we're making it a percent. Grams of hydrogen over total grams would give us a decimal, and then we multiply it by 100 to get our percent. So here's another definition. So it's mass percent is basically the mass of the element over the total mass of the element times 100. So we can also calculate the mass percent of chlorine and hydrochloric acid. It's the grams of Cl over total grams times 100. So that's how we calculate mass percent. It's like how much of the total compound does that one compound weigh as a percent. And we're going to do calculations on the next slide. I know this is a little abstract right now, but I hope you guys will understand it once we do a few examples. So we're going to go with water. So we want to find the mass percent of hydrogen and oxygen in H2O. So I'm going to start with hydrogen. It doesn't matter which one you start with, but I picked hydrogen since hydrogen was first. So after looking at a periodic table, you know that the mass of hydrogen is 1 and the mass of oxygen is 16. In H2O, the molar mass is 18 grams per mole. Because this subscript tells us we have 2 hydrogens. So 1 times 2 plus 16 is 18. And then we need to find the total mass of a hydrogen. So there's 2 hydrogens, so it has a total mass of 2. We want the total mass of all the hydrogen, so it's 2 grams per mole. So we're almost done. To find, I think I actually typed it. So the percent hydrogen is percent hydrogen equals mass of hydrogen, which is 2, over the total mass, which is 18, and then you multiply it by 100 to get it into percent. And you get 11.1%. So basically, we're just taking the mass of the element that we want, which is 2, over the total mass, and we're multiplying it by 100. So I hope that makes sense. I'm going to do one more example. We're going to do the opposite one. So we're going to do the mass percent of oxygen in water. So we know hydrogen is 1, oxygen is 16, and the total is 18. So the percent oxygen by mass is the mass of oxygen, which is 16, over total mass, which is 18, times 100. And then if we plug that into our calculator, okay, someone raised their hand. Did someone raise their hand? If you did, can you like unmute yourself and ask a question if you need help or something? I guess no one did. Oh well, we'll go back to the problem then. And you get around 88.9%. So that's how you do these problems. So you just find the mass of the element over the total mass. So that this 88.9% means that in any sample of water, 88.9% of the mass of the water is due to oxygen atoms. So that's basically what mass percent tells you. And of course, we're going to have some example problems where you can try this out. So, like I said, that's exactly the same way. So mass percent is mass of that element over the total mass times 100. So let's do this problem. So calculate the mass percentage of hydrogen in formaldehyde, which is this compound right here. It's CH2O. So calculate the mass percentage of hydrogen in this compound CH2O. And please put your answer in the chat when you're done. Interesting fact about this compound, CH2O, is that it's what they use to preserve biological specimen. So I found that to be kind of interesting. Oh, I'm so sorry. I forgot to give you the atomic masses. The mass of carbon is 12.
Mass of hydrogen is 1.
Yes.
Mass of oxygen is 16.
Yes. Good job. I'm so terribly sorry. I forgot to give you these numbers. And for these problems, please make sure to put that percent sign at the end so I know it's a percent and not a decimal. So I'll go over it just in case people still aren't understanding it as well. So mass percent of hydrogen. So we want the mass of hydrogen in the sample. There's 2 hydrogens, and each hydrogen right here is 1, so that's 2. Now we need the molar mass of formaldehyde. So that's 12 times 1 plus 1 times 2 plus 16 times 1. So this is 12, this is 2, and this is 16. 12 plus 2 is 14, plus 16, that's 30. So it's 2 over 30, and we want it as a percent. So we're going to times 100. So using your higher math skills or putting in a calculator, you get around 6.7%. So 6.7% mass percent means of all of the mass in formaldehyde, 6.7% of it belongs to hydrogen atoms. So that's all it says. 6.67, same thing. So now let's do the same thing, but we want the mass percentage of carbon instead. So please put your answer in the chat. Remember, carbon has mass 12, hydrogen 1, oxygen 16, and because we just did it, the molar mass is 30. Let me do it real quick. Okay. Okay. I see you guys are more confident with this one after that last example. So mass percent of carbon. It's the total mass of carbon, which is 12 times 1, which is just 12, over the total mass, which is 30 times 100. Sorry, this is a 12 right here. I have sloppy handwriting. And then once you get it, it's 40%. Yep. So that's good. So since we did C and H, of course, we have to now do O. So please put your answer in the chat when you got it. And as always, the carbon is 12, hydrogen is 1, and oxygen is 16, and the total is 30. Okay. I see that you guys are getting the hang of it. So mass percent of oxygen is the sum of oxygen, which is 16 by right there, over the total mass, which is 30, times 100. And we see it's 53.3%. So the oxygen atoms in formaldehyde actually make up majority of the mass. And yep, the answer key agrees, so that's good. I believe we have one more example left. So let's get to it. So this is a weird application of mass percent. So how many grams of carbon are there in 83.5 grams of formaldehyde? So this might be a little tricky, but the first thing to do is calculate the mass percent of carbon. So we know that how much of the mass of formaldehyde is actually in carbon. And then after that, we multiply it by our initial mass to get the grams of carbon. So I'll give you some time to think about it. It might be a little tricky at first, and I totally realize it. But the first thing to do is at least calculate percent by mass of carbon, and then you just multiply it by the original mass, which is 83.5. Since we're running a little short on time, I'm gonna go through this. So, like the previous example, CHO, carbon is 12, hydrogen is 1, oxygen 16, the total mass is 30, and the percent mass of carbon is 12 over 30 times 100. And I believe that's 40%. So we know 40% of the mass is from carbon. So 40% of 83.5 grams is the carbon mass. So it's 83.5 times 0.4. Sorry about that. I had a disruption. And then you get 83.5 times 0.4, and you get 33.4 grams. So it's basically the exact same thing we did in the earlier problems, but then we multiply that as a decimal to get 33.4. We got the 0.4 from here. So let's do another example. Wait. So like I said, it's 0.4 times 83.5, which is 40%. That's after calculating the percent by mass.
Mr. Jason, can I learn chemistry?
Sorry about that. So try this problem. It's the same thing, but it's grams of hydrogen. So please put your answer in the chat when you're finished with this problem. And to save time, we calculated this earlier. Percent by mass of hydrogen was like 6.7%. So you can use that because we already calculated it. Since we're a little short on time, I'll do it. So we basically take our total mass, 83.5 grams, and then we multiply this percentage in its decimal form. So what do I mean by decimal form? It's 6.7%, but if you multiply as a decimal, it's actually 0.067. So we basically just don't multiply it by 100 when we do the division. So we multiply it by this number, 0.067. And then once we do the calculations, 83.5 times 0.067, we get like 5.59 grams. So in an 83.5 gram sample, 5.59 grams are of hydrogen. So that's basically what it means. So here's the last problem for today. So give it a try. I hope that makes it a lot more sense. We're gonna review this next lesson at the beginning to just get into a refresher. So now let's do oxygen. So how many grams of oxygen are there? And as a hint, since we already did it, the mass percent of oxygen was like 53.3%, I believe. So I hope that helps you guys. Oh, and challenging problems like this one in particular, how many grams given a total gram size, would not be on our homework this week, but it will be on next week's homework. So sorry, I was texting or group chatting someone, but it will be on our next week's homework. So we'll have some more challenging problems like these on our next week's homework. But this week, it's going to be relatively straightforward, just calculating a mass percent. So a common mistake I saw on this problem is we need to multiply our mass percent in decimal form. So 53.3% It's 0.533. Because we don't want to multiply by an arbitrary larger number. If we multiply by 53.3, then we'll gonna get an answer that's way too large. So it'll be
Oh, 400.
what?
It's over 400.
What's over 400?
53 times 83.5.
Oh, yeah. That's over 400, so that would make no sense. We can't have more oxygen than the whole molecule instead. So remember, we need to multiply it in its decimal form. So doing this calculation real quick, I know we're almost out of time, times 83.5. A lot of people got it right. It was, let me quickly put in my calculator. It's 44.53. And as you can see, this is majority of the sample in formaldehyde, so we know we're correct. Okay, so recap, we converted between grams and moles today. There's going to be 2 problems on the homework, and we did mass percent, which will also be 2 problems in the homework. So I'll highly recommend you guys to look at the homework. It's on Google Classroom. There's 4 questions. And as always, if you have any questions, please contact me with this email. And thank you for attending class today. See you next week.
Bye.
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 Thanks. Bye.
Thanks.
Bye, everyone.
Thank you.